Welcome. In this lesson, we're going to talk about a new type of loop called an enhanced for loop. Let's get started. We have two learning goals for today. The first is that you can traverse an array using an enhanced for loop, and the second is that you can explain the limitations of an enhanced for loop. When we use a traditional for loop to traverse an array, we have a loop variable usually called I, and I starts at 0 and it keeps going as long as I is less than the length of the array. That I represents an index value, and we use that index value to access the elements of the array inside of the loop. Here's an example of what's called an enhanced for loop, sometimes referred to as a for each loop. This type of loop uses no indexes, and you'll also notice that the code is a bit shorter. So at the beginning of our for, we say for int item in our array called ARR. Now what you need to understand is that unlike the traditional for loop, item is not an index. It's actually a copy of the array element. So the first time through the loop, item will not be 0, it will be 4, because 4 is the element at the first spot. And the second time through the loop, item will be 0. And the third time through the loop, item will be 7. And the fourth time through the loop, item will be -2. And notice that -2 is less than 0, so that -2 will be printed on the screen. And the loop will continue. Item will be 11, and then finally item will be -5. That's the last element in the array. And if you see the if statement in the loop, basically we're printing the ones that are less than 0, which is -2 and 5. Let's look at another example of an enhanced for loop, but this time with an array of strings. So if we look at the top of the loop, we say for each string s in the array words. So notice that our words array is down here at the bottom, and the elements are indeed strings. And that's why we say for string s. S is not going to be the index 0, 1, and 2 like it would be with a traditional for loop. S is going to be the array elements. And for each of those S values, we're going to check the first letter. And if the word starts with an S, we're going to print it. So the first pass through the loop, S will be the word cat. Cat does not start with an S, so nothing happens. The second time through the loop, S will be the second element, which is sat. Sat does start with an S, so we will print that word. And finally, the third pass of the loop, our S variable will be the element, the word splat. This one also starts with an S, so our final output will be sat and splat. When we're working with enhanced for loops, it's very important that we understand what they can and cannot do. In this example, we say for each int item in the array ARR, item plus plus. The intent of this code is to increase the value of all the array elements by 1, but it won't actually change the array, and here's why. The first time through the loop, the item variable will be 4. But what we have to understand is that item isn't directly accessing the array. Rather, item is a copy of the array element. And if we increase the copy by 1, we actually have no effect on the array itself. Let's look at a very similar example, but instead of dealing with primitives, this one will deal with objects. And so in our loop, we say for each point P in the points array, take the x-coordinate of the point and increase it by 1. So in other words, 1, 2 would become 2, 2, 3, 4 would become 4, 4, and 5, 6 would become 6, 6 if each x-coordinate was increased by 1. Now, based on the last example, we might not think that this could change the array, but it actually does, and here's why. So we know the first time through the loop, P is going to be a copy of the first element of the array. But with primitives, the element is the actual number, so we make a copy of it, and when we work on the copy, we don't change the array. But remember that objects are stored as references. So P is going to not be a copy of the point, but it's going to be a copy of the reference. In other words, both the array and P are referring to the same object. They're aliases of each other. And so when we go to P and access the x-coordinate and increase it by 1, we actually are able to change the array. And the only difference is that with primitives, we're making a copy of the value, but with objects, the array element that we're copying is a reference. Let's look at a slightly different example with our points array. So again, we say for each point P in the points array, but we do something different in the body. We say P equals new point 0, 0. So the question is, will all 3 points in our array be changed to 0, 0? Let's find out. The first time through the loop, P is going to be a copy of the array element. Because we're dealing with objects, that means a copy of the reference. So P has direct access to the element 1, 2. Now, the next thing we do is make a new point 0, 0, and we say that P equals that. So what that means is that P used to refer to the first element of the array, but now it refers to this new point 0, 0. And notice that through that process, the array hasn't been changed. So initially, P refers to an array element, but assigning it to a new point changes that reference, and we cannot change the array in this example. Let's finish up by summarizing what we've learned about enhanced for loops. So we know that it's an alternative to a traditional for loop, and there's a couple advantages to that. Number one, the code is shorter, and number two, it's easier to read, but there are also some limitations. For one thing, it doesn't give access to an index value, and so if I need to know the index value, maybe I'm doing a search, and I need to know where what I was looking for was found. Well, I can't do that with a for each loop. And then, especially with primitives, it's not easy to change the array elements. And so if you need access to index values or you're trying to make changes to the array, probably a traditional for loop is going to be a better choice. Time to check your understanding. I've got some code on the right, and I'd like you to pause the video and see if you can figure out what the output will be. When you're done, unpause the video and we'll chat about the answer. This code loops through every element of the array, and it checks the elements to see if they're odd. And if the element is odd, it prints out the element times 2. So in this case, the if statement will be true for 5, 3, and 1. It will print out those values multiplied by 2, which gives us 10, 6, and 2. Now that you've watched this lesson, you should be able to traverse an array using an enhanced for loop and also explain the limitations of an enhanced for loop.